So there are multiple strategies you can go for when designing for adaptability and deconstruction. The first we'll look at is recycling. So if recycling is the goal at the end of construction, damage when you pull the building apart is acceptable as long as the materials can be separated. So decisions that here, some examples of some of the decisions here, you actually might be better off using traditional reinforcement, steel reinforcement, as opposed to fibre, as it is much easier to separate at the end of the building. But if you look at the whole life cycle of the two products, you might end up better going up with the fibre reinforced concrete. Another one is looking at the reuse of the building. So at the end, the goal here is to remove the members easily with no damage, because obviously you want to be able to reuse these elements again. So one of the really important things here when designing for reuse is simplicity. So simple buildings with independent systems. So the contractor needs to easily identify the framing layout, the beam sizes, the geometry, and the load paths. And you need to be able to identify its durability. So, you need to ensure the disassembled elements have a long life for reuse. So at the end of this building's life, can it withstand the intended building life of the next building? Another big thing for reuse, as I said, you need to be able to remove the members easily without damage. So something really important here is the material and connection choices. So cast in place concrete represents a major obstacle for design for adaptability or deconstruction, as if you think of, say, two precast panels on top of each other, and then you put inside in the middle the topping slab, and then it essentially makes one continuous joint, and then it's very hard to disconnect without much damage. So another thing is many of the elements in the building are designed for a particular application, and it makes it unlikely to suit a new project if you've got cast in place. And one really important thing is to be able to identify where the reinforcement bars are as you can't see this from the exterior, obviously. So again, as-built drawings are going to be crucial for this. Another important thing is to use very simple connections with clear load paths, and mechanical fasteners might be the go here. Standard details and components, and use fewer large members than many smaller members. Another important thing is to be able to identify materials and elements, and this is going to be much easier in future with building information modelling. So having the engineer model everything or have all the information inside the model, in future people will be able to identify what every single element is within the building. So what is the case for reusing an existing building as opposed to demolishing it? There's obviously a huge sustainability benefit right there, as opposed to knocking down a perfectly good existing building and all the construction involved in producing a new building. Sometimes you might be better off just reusing and adapting the existing. So some of the things you need to do first is you need to remove all the features of it. So it's just the bare bones of the structure there. So, ready for inspection by the structural engineer. So buildings with good bones are considered the best to be able to reuse or for a new purpose. So one of the things you need to do in this process is to test all the concrete elements to make sure that the concrete strength is at least what is specified on the as-built drawings. And you need to look at the existing drawings carefully to evaluate the purpose of the building and some of the detailing and reinforcement, but that's one for the structural engineer. And you need to check the condition and durability. So pay attention to big cracks that will suggest that the building is not so durable and there has been a bit of wear and tear due to some of the freeze kind of thaw or hot cold cycles for the building. And finally, you need to match the loads of the existing building to the what the architect's plans are for the next building. So something like a loading plan will be able to do the job for this.